Yes, 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 yes.
I can't see it.
Success. At last.
You send me the video link. Hi, there we go.
Oh, I can't see it. Why can't I see
Found
it?
it.
There we go. There we go. Yes. Twitch ping everyone.
It's like, huh, they're working.
Yes.
Just keep publishing all the other ones.
All right. Hello. I don't have my audio on. I think Harry, can you have? Well, you don't have to have it. Never mind. But let me
Okay.
turn on my audio. Actually, no, I'm not gonna turn on my audio. I think that's gonna be very bad. Will it bad? I don't know if it'll be bad.
Okay.
Oh,
Hello,
it.
everyone.
Oh, I hit it. When I was typing hello, I opened up the first question. That's not good.
Um,
But I guess I'll get started. Should I just get started?
Go ahead.
All right. All right. So let's just begin 8:45. So technically I have to go until 9:25, but I might go over because I'm going to explain the prompts as I do them. Hopefully I can do all of them. All right. So Luca's making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar. Okay. What? 4 times? Okay, wait. Okay. So he has uses 3 cups of lemon juice, twice as much sugar as lemon juice, which means that lemon is equal to 2s, right? Am I being stupid? Because my brain is fried from. Oh my god, oh no. Oh, yeah, so that means sugar is equal to 6. Uh, 4 times as much water as sugar, so 6 times 4 is equal to 24. The answer is E. So there it is. That's the first answer.
I have to say, unfortunately, you are incorrect.
Really?
Yeah, the answer is F.
Okay. Thank you.
Yeah, that's disappointing.
All right, so let me just scroll down. Wait, I think I hid something. No, I didn't. Did I? That's the next thing?
Stop
Okay.
close. Stop
Uh,
killing our like to dislike ratio. We don't appreciate it.
it's fine, I guess. Okay. I'm trying to make the thing. Okay, there we go. Let me. I'm using hotkeys. Like this is a slideshow, so I can't see the problem on my screen, but you guys can. Okay, there we go. It's on the screen. So, okay, so let me just draw this line so I know what I'm doing. It might not be the right place, but it's okay. So 4 friends do yard work for their neighbors over the weekend, earning 15, 20, 25, and 40 respectively. Decide to split their earnings equally among themselves. In total,
You kind of cut the problem in half.
that's okay. Okay, so how much will the friend who earned 40 go to the other? So 15 plus 20 plus 25 plus 40. So the first three are in arithmetic sequence, so that's 60 and then 100. You divide by 4, you get 25. So the guy paid 15 to the others. Unfortunate. That's a lot of money. Uh, yeah. My stream is not on par. I'm just gonna keep on going. Tell me if there's anything wrong with my configuration, okay? And tell me if I did anything wrong.
Okay, who's commenting under cyclic national competitive? Is that the actual account that we have?
Okay, if I make any mistakes, let me know, okay?
Wait, I think that's the actual cyclic like CNCM
Yeah,
account.
that is the actual
That's
CNC map. Yeah, okay. If I make any
who's
if
commenting.
if I make any mistakes, let me know. This isn't a mock. This is a live solve. I tend to do everything accurately. All right, number 3. So I'm gonna read off my paper here. Carrie has a rectangular garden that measures 6 feet by 8 feet. Uh, she plants the entire garden with strawberry plants. Carrie's able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. All right, 6 feet by 8 feet. So that's 48 square feet. Uh, yeah, 4 strawberry plants per square foot, so that's gonna be 48 times 4, which is 192. And then she harvests an average of 10 strawberries per plant. So that should be 1920. So that should be D. So that's done.
Yes, I would like to clarify my statement. Like CNCM has two CNCM email accounts. There's the CNCM and there's Cyclic National Competitive Math Group. One is the bigger logo, one is a smaller version of that same logo. So that's what I think that account is. I don't think it's fake. It's just using the other account.
All right. So so Lily, I'm watching my own stream and I'm waiting for the. So here's the thing. I can't see the problem on my screen that you guys can see. I know it's kind of weird.
Did you just move that up into oblivion?
Yeah. Look, I can't see the problem on my screen. I have to look at it on the YouTube channel. All right. So 3 hexagons of increasing. Okay, Harry, make sure I'm doing everything right. Don't let me make a mistake. Okay.
Sure.
3 hexagons are increasing. Okay. Suppose the parent contains how many dots are in the next hexagon? So that's 1. There's 7, and then that's another. Like count the dots on the screen. 1, 2, 3, 4, 5, 6. That's like another 12. So this increased by 6. This increased by 12. So that's 19. So this should increase by 18, if I'm correct, because you're going to add another dot in between. Like you're going to add. It's like kind of hard to explain, but you're going to add a dot in each gap. Then you're going to add the edge dots, which adds another dot per like side. So it's 19 plus 18 is 37. Should be B. Trying to explain this as well I can. Like, I can't draw on the image because, well,
Essentially, you can split the next hexagon into six lines of dots, all with 3 dots inside of them. So six
yes,
times three is 18.
yeah. Man, why are there 3 downvotes? I don't know. Okay, let's see if my
Stop
hotkeys work.
downloading us.
Now it should
You
go
not
to the
like our
next problem.
content?
What?
They not like our content or something?
What do you mean, not
Mm.
content? I'm confused by what you're trying to say.
Do they not like our content or something?
I
We
guess
have
I
three
don't like our
dislikes.
content.
Hey, we have a 2-to-1 like to dislike ratio.
Okay,
Okay, thank you.
3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice in each of the 5 cups. What percent of the total capacity of the pitcher did each cup receive? So 3/4 of the pitcher is filled with pineapple juice. So let's just say there's like 100 stuff in the pitcher. So then there's 75 stuff right now. Because 100 is the capacity. There's 75 stuff. And each cup receives 15, which means 15%. Like for these type of problems, assume there's like 100 units. Because then it's very easy to calculate stuff. That should be C. Let me know if I make any mistakes, okay? Did I do everything right so far?
I
I'm
don't know
not.
if necessary. You could have just used. You have to assume it's 100, just like percent or
Yeah, but
something.
like I like assuming 100 just for fun.
It's like it's the same thing though. It's like 100% of the pitcher
Oh,
first and 75% of the
well,
pitcher.
I mean, I would have to be perfect. Let's see
Yeah,
if
but
my
it's just like
hotkeys work.
it's just kind of like yeah. It's just, you don't have to assume though, and you get the exact same calculations. It's more
Yeah,
technically correct, I would say. I would say.
technically I am
So we.
correct. Okay, Aaron, Darren, Karen, Marin, and Sharon. Okay, it's an interesting set of names.
Oh my God.
Rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car. Okay, so I'm assuming this is like a counting question. So let's say this is the last car. So this is where Marin is. Aaron sat. Oh, this is a. Okay, this is a logic. Okay, Aaron sat directly behind Sharon, which means Aaron can sit either here, here, or here. And Darren sat in one of the cars in front of Aaron. Oh, so
Why is Marin even in this question? Marin doesn't interact with anyone.
I don't know. Okay, listen. So
You
this
could
means that
just
there's two
remove
people.
Marin. The
This
question
means
is the
that there's
same.
2 people ahead of. So Sharon and Karen are ahead of Aaron. So these are the only 2 spots that Aaron could be in. At least one person sat between Karen and Darren, uh, which means that Karen has to be here in the 4th spot because you can't put both because at least one person sat between Karen and Darren. That means there's only 2 cases. Either Karen is in front of Aaron or behind Aaron. If Karen was ahead of, wait, hold up. Not okay. That's not what I said is not necessarily true. Wait, doesn't this have multiple solutions?
It's possible that it has multiple solutions, but
Oh
they
wait,
all
never
have the
mind.
same number.
Aaron sat directly behind Sharon. Like I did not see that. That's my fault. which means that let's say Aaron sat here, that means Sharon would have to sit here, but there's no way to put Darren and Karen like with one person in between each other. So you have to put Aaron here, Sharon here, Darren here. So let me put this. Darren, Sharon, Aaron, Karen, Marin. This satisfies the last spot. Uh, there is at least one person between Karen and Darren, and Sharon is directly in front of Aaron, so Aaron's in the middle seat. That is A. Who am I? I don't know who I am. Thanks for asking.
It's
Uh,
an age-old question.
I'm assuming I did everything correctly because no one has like called me out on anything.
Nobody's screaming at you. Who are you, CNCM? Well, I am currently
Okay,
in the
how many
CNCM
integers
account.
between 2020 and 2400 have four distinct digits arranged in increasing order? Four distinct. Interesting. So obviously, 2400 does not satisfy the requirements. That's just the way it is. Um, Anything below 2020 and above 2000 does not satisfy the requirements because 20, that's not increasing order. So we can basically treat this as from 2000 to 2399. We can rewrite the problem like that to find the number of numbers between 2000 and 2399. So that means we can use the digit, we can only use the digit 2 at the front. We can use 0, 1, 2, 3, but we need to put a 3 here because yeah, uh, everything else ruins the conditions. Wait, let me check Discord. Something is happening. Oh, okay, never mind.
Yeah, I kind of got disconnected for a
Yeah, so
moment.
that means the second digit has to be 3, so you have 2, 3. And now you have two digits that have to be in increasing order after 3 that are greater than 3. So it can be like 4, 5, 6, 7, 8, 9. Why couldn't I have said what in the first place? What are you talking about? So this is just going to be 1 plus 2 plus 3 plus 4 plus 5, which is 15. Should be 15. Let me make sure. Because 2400 does not work, anything below 2020 doesn't work. Uh, has to be 4. Oh, oh, the reason I did is because uh, I just wanted to deal with like now, because now you know that the second digit has to be between 0 and 3. The third digit has to be between 0 and 9, and the fourth digit has to be between 0 and 9. I just did it because it helped me kind of, do this a bit more correctly. But you don't have to do that. You didn't have to do that. Because you get that 3 has to be the second digit anyways. So, yeah. So it doesn't really matter. You can rule out 2400 and you can only have this fixed as 3. But this should be 15. That should be C. I don't know why I circled 3 there. No one has called me out on anything yet. I'm assuming I have not made any mistakes, but if I have, let me know. Let's see. Let me go into 8. Let me check Discord. People will probably call me out on Discord. No one has called me out on Discord. Perfect.
Well, this one's easy.
Oh, okay. The next promo. Okay. Ricardo has 2020 coins, some of which are pennies, 1 cent coins, the rest of which are nickels, 5 cent coins. He's at least one penny and at least one nickel. What's the difference in cents between the greatest possible and least possible amounts of money that Ricardo can have? Well, the greatest possible amount is 1 plus 2019 times 5, because you need at least uh 1 penny and 1 nickel.
You didn't move to the next slide.
Did I skip a problem?
No, you just didn't. You just didn't move to problem 8.
Yes, I did. I think your stream is
Well, now
weird.
you did. I
Well, I
think the
think your
easiest
stream's really
solution
weird.
number 7 would just be to do.
And
Notice
then,
that it's just like n choose 3. I believe the answer is. It's just 7 choose 3, and that's the
yeah,
answer.
well, you can do that as well. But, well, it's not 7 choose 3. It's,
Something choose 3.
it's something choose 2, I think. Yeah, it's 4, 5, 6, 7, 8, 9. That's 6 choose 2, yeah, which is the easier way to deal
Uh,
with it. And then, so, okay, go on to this problem. You have, I was talking about the last problem, it's just a comment he had. So let me talk about this problem. So since you have to have at least at least one penny and one nickel, uh, the maximum is 1 plus 2019 times 5, and the minimum is 5 plus 2019 times 1. So if you subtract this, you get 2018. Like don't like, add them up. Just subtract like this. You get 2018 times 5 minus 2018 times 1, which is the same thing as 2018 times 4, which ends up being 8072. And that is C. All right. We're on a roll. No one has called me out on anything. I'm confident I've not done anything bad. Hopefully. All right. Let me see if my hotkeys are still working. This is really cool, this whole slideshow thing. I like it.
How do you write for the AMCA? Because like some of these questions feel so like they are very easy, obviously, because they're for
Okay, a
like
cautious birthday cake is in the. Okay, I may need to read my paper for this instead of the stream. A cautious birthday cake is in the form of a 4 by 4 by 4-inch cube. The cake has icing on the top and the 4 side faces, and no icing on the bottom. Suppose that the cake is cut into 64 smaller cubes, each measuring 1 inch by 1 inch by 1 inch, as shown below. How many of the small pieces will have icing on exactly 2 sides? So you can either have icing on 3 sides, which is the corners. Uh, you can have icing on 2 sides, which is the edges, and this is what we want. They're on the edges, but not the corners. So you need to know that the bottom face doesn't have icing. So the number of edges on a cube is 12. So 12 times 2 gives us 24, but that's not the total amount because the bottom face has been erased, which means we have to remove 8 from this total. But the 4 corners on the bottom that originally had 3 faces iced, now they have exactly 2 faces, which means you have to add another 4 to this count, which means it should be 20, which is D. I think I did that correctly. Should be correct. And that is, yeah, that's 20D. So yeah, we just had to, so there's 12 times 2, 24 edge pieces. We had to remove the 8 on the bottom because the bottom is not iced. But since the corners have exactly 3 faces iced, if you remove the bottom face, the bottom 4 corners actually have only 2 faces iced now. So that's why we had to add, that's why we had to add the 4 back. So I don't know why I put a minus there, but yeah. So 24 minus
no
4
one's
equals 20.
watching the stream.
Oh, Noah said so troll. Oh, is this the problem that people were talking about? Like, I don't, people were talking about a problem that tripped them up. I think this is the problem they're talking about. Yeah, that's a bit tricky. It's a bit tricky. All right, let me move on.
Hello, Noah.
Hello, Noah.
Who's Ishan Panagrahi? Is that Vivid?
I'm not gonna Discord reveal him. All right.
Well, okay.
Zara has a collection of 4 marbles, and Aggie, a bumblebee, a steely, and a tiger. Are these actual marble terms? I don't know. She wants to display them in a row on a shelf, but does not want to put the steely and the tiger next to one another. This is a very typical problem, very standard. So you have use complementary counting for this. We want to find the number of configurations that have steely and tiger next to each other. So if we put, so let's say this is steely and tiger, and then we have A, B on the other thing. That's 3 factorial times 2 configurations because you can move these 3 objects uh, 3 factorial ways, and you can multiply the order here times 2. And these are the configurations we don't want. So the total number of ways to organize the marbles on the shelf is 4 factorial, so we subtract, we get 24 minus 12, which gives us 12, which gives us C. So far, no one has called me out on anything. I hope I'm doing stuff right. Harry, have I made any mistakes yet?
I don't believe so. I don't actually know the answers.
Okay. People in the chat, have I made any mistakes? I haven't been recording my answers, by the way. Let me just do that real quick. Should probably record them somewhere. I'm just gonna record the answers on my sheet, so I guess I can check them later. I don't know. Because you guys aren't saying anything, so I don't know if I'm doing anything wrong. Like I circled everything. What's this? All right. After school, Maya and Naomi are headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi's and Maya's average speeds? So average
You.
speed is the total distance traveled over the total time. So from this graph, we can see that Maya has traveled 6 miles in total over 30 minutes. So 6 miles over 30 minutes, which is half an hour, which that means she's traveling at 12 miles per hour. That is Maya. And for Naomi, she traveled 6 miles in 10 minutes, which is 1/6 of an hour, which gives us 36 miles per hour. The difference is 24, and that is E. There we go. Uh, let me make sure that's correct. It seems wrong for some reason to me. Why does it seem wrong? This seems wrong to me.
I don't know. This problem looks really annoying. It probably is, honestly.
6 over. I'm not gonna question. I think this is correct.
Oh, I can take a look at it, I suppose.
It's simple. It's just I think I'm right. I don't think I made a mistake on this one. If I did, I'm bad at math. So I don't know. I was looking at the differences and it didn't make sense, but I think I'm just being dumb. So I'm gonna use the hotkeys again and see if it moves on to 12 for me. Yeah, I can't see these problems on my screen, so I might write over them. I'm literally looking at my
Wait
own
a
screen.
second. No,
What?
you're correct. You're
Okay,
correct, I think.
okay. For a positive integer n, the factorial notation n factorial represents the product of integers from n to 1. That makes sense. What value of n satisfies the following equation? So if you divide, so you have 5 factorial. This is probably going to be a bit greater than 5. Actually, let's not do that. So we have 9 factorial, 9, 8, 7, 6, so on. So this answer is going to be a bit greater than 9 factorial. So 120, which is, wait, yeah, 5 factorial is 120. If you divide that by 12, you get 10. So this is 10 times 9 factorial, which is 10 factorial, which is A. Just some simple stuff. Yeah, nothing too much to add on there. Nice little problem. All right, 13. If I can find 13. There we go. Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed. Wait, Jamal?
Mole.
I don't know. Notice that there's now
Mole.
60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? It's Jamal. I don't know why I thought there was an O there. Okay, so the total number of socks is 36, and there's 18 purple socks. So 18 plus x over 36 plus x is equal to 3/5. So you can cross multiply, you get 90 plus 5x is equal to 108 plus 3x, which gives you 2x equals 18, x equals 9. You can test it. That gives you 27 over 45. Dividing top and bottom by 9 gives you 3/5. So he did indeed add 9 purple socks, which is B. All right. Let me note down these answers so I can check them later. But I'm pretty sure I didn't make any mistakes. Okay, number 14. Let's go on. Where is 14? Can you show up, please? Number 14 on my screen. There we go. Yay. All right. There are 20 cities in the county of Newton. Like I need to read this in my paper. There are 20 cities in the county of Newton. Their populations are shown below in the bar chart below. The average population of all the cities is indicated by the horizontal dashed line, which of the following is closest to the total population of all 20 cities. What? All right, so this seems like a bounding problem. So the graph, the average is clearly between 4,000 and 5,000 if you read the graph. So that's going to help us, I think. And how many? There's a total of 20 cities. So the average, we had the average. So if we multiply these by 20, we get that the total should be between 80,000 and 100,000. And that's either 85K or 95K. Now 95K, well, if you look at the average, it's closer to 5,000 than 4,000. It's actually really close to 5,000. So the answer is 90,000. Well, 95,000, sorry. This one you have to use the answer choices for. Um, so you get that the viable ones are 85K and 95K, but you can say the average is closer to 5,000, so that means it's 95K, which is D. That's correct. Now let's move on. I'm too old for AMC. I am, but I'm live solving it just for, why not? All right, suppose 15% of X is equal to 20% of Y. I'm going to fix X is equal to 100 because this will make our calculations a lot easier and you'll silly a lot less. I don't know why I wrote that up there. Well, actually, that's fine. X equals 100. That's gonna make stuff much better. So we get that 15% of X, which is 15, is equal to 20% of Y, or also 1/5 of Y, which means that Y is equal to 75. And that means that since we know X is 100, Y is 75% of X. Done. Simple problem. For these problems, it's kind of easy to make dumb mistakes, so just let X equal 100. It makes it much easier. Just do that. Because then you can easily find what percentage of X is Y. You can just read it off the answer. I suggest you guys do that. I like letting things be 100 because it's much less likely to make a mistake. All right, let's go to 16. I think 16 is a problem I have to read my paper for. So each of the points A, B, C, D, E in the figure below represent a different digit from 1 to 6. Each of the 5 lines shown below passes through one of these points. The digits along the line are added to produce 5 sums, one for each line. The total of the 5 sums is 47. Interesting. So this is simple. So what you want to do is you want to assign a weight to each point, and that weight is how many lines go through it, because that's how many times the value gets multiplied and contributes towards the sum. So C is in 2 lines. Well, let's go from A. So A is on 2 lines, so it's going to be, let me write this here, 2A. Uh, B is on 3 lines. Hold it, where did I write 2A? Oh, I wrote it behind. Oh no, I didn't write it behind the image. Okay, 2A plus 3B. C is on 2 lines, so plus 2C. D is on 2 lines, so plus 2D. E is on 2 lines, so plus 2E. And F is on 2 lines, so plus 2F. But this is equal to B plus 2 times A plus B plus C plus D plus E plus F, which you know is the sum of 1 through 6, which is 6 times 7 divided by 3, 14? No, 6 times 7 divided by 2. 6 times 7 divided by 2, 21. So B plus 2 times 21 is equal to 47. B plus 42 is equal to 47, which means that B is 5. And that is E. Harry, are you still there? You kind of went silent.
I am. I'm just not really saying
Yeah, no.
much stuff.
All right.
I have to deal with some stuff right now.
Yeah, I understand. Okay, what's the next problem? 16, no, it's 17. How many factors of 2020 have more than three factors? As in, example 12 has six factors, namely 1, 2, 3, 4, 5, 6. All right, to look at this, this is actually an interesting problem. So you know that 2020 is 2 squared times 5 times 101. 2020 itself has 3 times 2 times 2, 12 factors. So to have more than three factors, let's consider the number of factors that have less than three factors. So how do you make less than three? Well, how do you make three? For three, you need a prime squared. For two factors, you need just a prime. And for one factor, well, that's just one. So let's see how many ways we can make a square. Only two squared satisfies that scenario, so there's one factor that has three factors in total. Uh, a factor having just two factors would be either two, so it'd either be 2, 5, or 101. That's three factors. And one has one factor, so we add that to our total. So that's 12 minus 5 is equal to 7. Very pro explanation. Oh, thank you. So that is the answer. B equals 7. B. There we go. Yeah, make sure. Okay, if I make a mistake, let me know, because I'm very dumb. But I think that should be correct. Let me just check through it. Yep, it's correct. Should be. Is it? Yeah, it is. Okay. Why do I have my eraser open? Let me. Oh, thank you, the media math. I really appreciate that. Uh, I I was gonna watch your AMC8 Livesolve video, then I realized if I watched your AMC8 Livesolve video, then what's the point of me doing an AMC8 Livesolve? So unfortunately, I did not watch your video. I was there for the beginning, but yeah. But you have a great YouTube
Paradox of
channel. I really appreciate what
paradox
you've
of life.
doing. Yeah, it wouldn't be a Livesolve if I watched that. Uh, all right. What's the next problem? Like I had to use my right arrow key. Does that work? All right, 18. I might have to read this on my paper. It's not loading. There we go. Okay. Rectangle ABCD is inscribed in a semicircle with diameter FE. Okay, as shown in the figure. Let dA equal 16. I have a feeling that FE might have been intentional, just to represent functional equations. FD equals AE equals 9. Let me just draw a rough sketch. Okay, that's not a semicircle. That's like a hill in Super Mario Bros.
Looks like what if that's just literally a square? I don't think it's a square. What if it's just a square?
It looks a lot like a square, but let's not assume things.
It's clearly not a square though.
Yes, I don't
It
think it's a
can't be.
square.
It can't be a square. Come
It can't
on.
be a square. All right, so we have that. So the radius is 9. Oh, we're supposed to find the area of the rectangle. Okay, so this
You think
is
the
8.
radius is 9?
Oh shoot, no. I would have got this problem wrong then. The radius is 17. Actually, I wouldn't have gotten it wrong because it would have given me a radical answer. So
No. Well, yeah.
but yeah,
True.
the radius is 17. The radius is 17.
You
Uh
still wrote 9 though. Oh, there
wait,
you
this is
fixed it.
9
Okay.
plus 8. The radius is 17. So 8, 17, this is a 15, 8, 17 triangle. You can use Pythagorean theorem to get that. So the area of the rectangle is 15 times 16 equals 240, which is A.
Imagine not memorizing all of the Pythagorean triples.
Yeah, 8, 15, 17. You can use Pythagorean theorem. 289 minus 64 is 225. Square root that. But yeah, so there it is. Let me write this down somewhere.
All
What?
these problems make me wish that I like studied for the aims, like I actually studied math in middle school. Then I could have gotten like a decent score.
Oh, okay, let's not say that in the chat, bruh, no you stalkers or whatever.
Clown.
Do not call people that, please. Thank you.
It was very clearly a joke.
Yeah, I know, but still.
Rising by finger and triples is clearly not the best usage of your time, typically.
Okay, let's see if
Guys, you
19
guys
loads.
you guys know that 15, 20, 25 is Pythagorean
Like I, I,
triple.
I think in 8th grade I got 23. I remember I
Ooh.
studied 25 and I didn't understand what 23 was saying that year. So I just
Uh,
got 23. That was like 3 years ago though. It's a long time ago.
I have no idea. I think I had like an 18 or something. I have
Okay,
no idea.
apparently so there's some like formatting, it's fine, that's supposed to be italics. So a number is called flippy if its digits alternate between two distinct digits. For example, 2020 and 37373 are flippy, but 3883 and 123 123 are not. How many 5-digit flippy numbers are divisible by 15? All right.
Weird problem.
So let's consider it being divisible by 3 and being divisible by 5. If it's divisible by 5, the last digit has to be either 0 or 5. But it can't be 0 because if you actually list this out for 5 digits, you get that the first digit has to be 0, and that's illegal. The last digit has to be
Illegal.
5, which means that we have this. 5, 5, 5. That adds up to 15. So the other two digits have to sum to a multiple of 3. But since they're the same digit, they have to be a multiple of 3. That means it can either be 0, 3, 6, 9, which gives us
Whoa.
4 numbers. That is B. So yeah,
What a
just
high IQ question.
split that up. That's a nice. I like that question. That's a nice question. I like that.
Yeah.
All right, going on to number 20. Oh, we're about to hit the 40-minute mark soon, but I've been explaining these, so I'll just finish it off with all 25. Because what's the point?
Someone score Akshar when he reaches 40 minutes.
Well, okay. I mean, people people would have called me on my mistakes if I made any mistakes. So,
But they should still score you. Come on.
a scientist walking through a forest recorded as integers the heights of 5 trees standing in a row. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Unfortunate, happens to all of us. Her notes are shown below with blanks indicating the missing numbers. Based on her observations, the scientist was able to reconstruct the lost data. What is the average height of the trees? Interesting. So, uh, let me just make some blanks here. All right, so the each tree is either twice as tall or half as tall as the one to its right. So for 11, this is this number is either half. Okay, 11 is either half of the next number or twice the next number. Now these are all
Yes.
integers. So if it was twice the next number, then the next number had to be 5.5, which is not good. Which means the next number has to be 22.
Oh, wait, no, I think they can be decimals.
I
Can
think
they?
it says
No, they're
recorded as
integers. Sorry.
integers.
Correct. Sorry about that.
Yeah, and for this first tree, uh, 11 divided by 2 would be 5.5. So this can't be 5.5. You can't have it be half of the next tree. It has to be twice the next tree, which is 22. So going on, now here you hit a roadblock. This could either be 11 or 44. And similarly, this can either be 22, and this could either be 22 or 88. We have to look at all of these because there is some important information in the question. It says that the average height is something 0.2, which means that the average height, well, the sum of the heights is 1 mod 5. That's the only way you'd get a 0.2 in the average when dividing by 5. The sum is 1 mod 5. So far, the sum is 55, which is 0 mod 5. So the sum of these remaining numbers has to be 1 mod 5. So let's look at the 11 root of the tree, I guess. So 11 to 22, that gives you a sum of 33, which is not 1 mod 5. 44 to 22, that gives you a sum of 66, which is 1 mod 5. And the other condition gives you like 132, which is not 1 mod 5. So these remaining blanks have to be, let me erase all this. The remaining blanks have to be 44 and 22.
Yes, yes, it should be. This is
And
a
so
very
this has a sum of
important.
66. We know the top has a sum of 55. So this sums up to 121. Dividing by 5 gives us 24.2, which is
Oh,
B.
it's completely amazing.
We have 18 likes. Wow. Thank you guys. We have it 3 to 1. Oh no, we have it. No, we have it. Yeah, 3 to 1. Like this.
18? I want to be 11.
Oh, I don't know. I think yours is kind of behind. Oh yeah, on to the final 5. Wait, is my stream? Okay.
19? Is mine not loading? Let me refresh. Whoa, that's a lot. Okay. But there's like 6 dislikes?
That's fine.
What?
Good night too. Good night to you,
It's not-
Media Math. Thank you so much for coming here and
Yes,
watching.
thank you.
Thank you everyone for watching so far. We're almost done here. We have 5 final questions to go through. Okay, a game board. Wait. I almost stabbed myself in the eye.
What?
Yeah, I was
You
picking up my
okay?
pen and I almost stabbed. Like, I could have lost my eyesight there. That was not good.
Okay, well,
Well, luckily I was
yeah,
saved.
they never tell you this, but math is actually very, yeah, hundreds of
Let's get the final 5
mathematicians.
done. Yep, let's get the final 5 done. Alright, a game board consists of 64 squares that alternate in color between black and white. The figure below shows a square P in the bottom row and a square Q in the top row. A marker is placed at P. A step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? This is an interesting question.
Can you just bash this?
Well, I think you can. So,
I think backwards counting works.
so you, for this problem, there's 2 options. You can either move, when you move up, because you'll obviously make 7 moves up. That's kind of given. But we're going to look at the direction you go. So you can either go to the left or to the right, 1 square. And we can denote this by a -1 and a +1. All right. Overall, we want a +1 at the end of the day on 7, which means we need a 4 minus 3. That's the only way that can happen, which means we need 4 right moves and 3 left moves.
Actually, I would be careful with this because the bolt you can't go all the way right and then
Yeah, I
the other
know.
back left.
So for this, yeah. So as you said, you can't go all the way right, which means that there's some cases you have to disregard. But for the initial count, in fact, actually, hold up.
I really would not recommend this way.
Let me think about this. I think I could make this way work.
There's a much easier way.
It's fine. This is 7 choose 3 total ways, by the way, which is 35, but that's not the total because you have to subtract some. And the things you subtract are there being you need like 2 left moves before right moves, which means that That's a bit of casework, isn't it? You can either have LLR, RRR, or you can have some combination of LLRR at the start. I know you can't go RRR. Thinking about this. Should I proceed? Or you can have LRRR. So these are the three cases. So you can have this, which is one way. Let's just start with the legal ones. All right, so this is one way. After this, these are just RRL, so there's 3 ways to organize this times 6 ways to organize that, so that's 18. And LLR, there's 3 ways to organize this and 4 ways to organize this, which is 12. 31 is not a choice because there's also... Dang, am I messing this up? Oh no, because the R case, this is 4. You have 4 stuff here. Well, hold on, I'm messing up, bruh. Wait, my work is off the paper. Okay, let me
Oh my god.
let
Okay,
me
it's not really.
re-explain.
It's not. In my opinion about this is there's an easy way to do it, but I don't think it's still not really a good problem.
My method works. I just want to say this. So yeah, we can assign
Actually,
each.
do you want to show what my method is?
Yeah, let me just do this real quick because I'm almost done. So left
You haven't
plus 1
finished?
R
Okay.
minus 1 L, which means you have to have 4 R's and 3 L's. So this gives you 3 cases. You'd have 1 R in the first few, which is L L L R R R R. This is going to have 4 solutions. You can have 2 R's, and the remaining will be RRL. This will have 3. This will have 6. If you multiply those, you get 18. Because you can go right 2. And finally, you can have 3 R's, and you have to go left first in this. Actually, no, you don't have to go left first, but you either go left first and then move right 3, or you go right first and then move left and then move right 2. But you can't move. You can also move 2 right, and then you can go like this. But you can't have 3 R's at the start. So this gives you 3 cases. Hmm. Man, I'm blanking on what am I doing? Oh, I put 5 R's here. Like, no, I didn't put 5 R's here. What? So you can either have 1 R in the first 4, you can have 2 R's in the first 4, or you can have 3 R's in the first 4. What am I doing wrong? I clearly missed something. Right, right, left. What am I missing? It's kind of crazy. Oh, I'm stupid. There's an RLL at the end of each of these. There we go. All right, and so in this case, so you're guaranteed not to do anything spam here either. So we have to be a bit careful of these. So left, right, right, right. That's at the edge of the board. You have to have a left here. And then there's 2 cases in this one. This has to be a left, and you can organize the right and the left 2 ways here. For this, right, left, right, right, you're going to end up once again at, yeah, so you can't, okay, so in all these cases, you're going to end up with a +2 config. You have to go left, like on the next move. And then you can organize the right, left 2 ways. So this is just 2 times 3 this case. So that's 6 plus 4 plus 18, 28, which is A. All right, Harry, you can share your solution now.
Yeah, there's the recursive solution. So basically, we know that the amount of okay. So let's let basically we can number each white square the amount of ways the what's it called
Yes.
the marker can get from that square to Q.
Hmm.
So basically, we can just kind of mark it repeatedly, starting from Q. So the two white squares below Q, we can label 1 and 1, obviously, because there's only
Ah,
one
I
way to
see what
get
you
there.
mean. It's like a grid
And then
walking
one,
problem.
yeah, and then 1 and 2, 1, 3,
Yes.
2, and then continue
What it
down
means is
onto
you can
the
go
Q.
Q, 1, 1, 1, 2. This is the edge of the board. Then you can go 1, 3, 2.
Yeah.
Then you can go 1, 4, 5. This is 1, 2, 3, 4 down. Then you can go 1, 5, 9, 5. It's 5. Sixth row.
You don't have to keep going left. You can just kind
Yeah,
of
I
you can
know, but
ignore the first
I'll
one.
do it for the sake of example.
Okay.
14, 14. And finally, the P square is like here, I think. It's right there. There's a blank here, which is 14. Yeah, so that's also how you can do it. That's probably a better way.
It's still back, but it's a lot faster and a lot
Yeah, it's
easier.
lost faster than what I did, yeah. Uh, let's go into 22, because that took a while, unfortunately. Because well, I use the correct solution, not the fastest solution. Let's see what 22 is. Yay, oh god, what is this? What type of spam am I looking at? This is split on 2 pages on my sheet of paper. Alright, let me read this problem
What in
for a
the
second.
world?
N is put into this function machine, so if n is even, uh, it outputs n over 2, and if n is odd, it outputs 3n plus 1. For example, starting with an output and input n equals 7, the machine will output 3 times 7 plus 1 equals 22. Then if the output is repeatedly inserted in the machine. Okay, what is
This
some
is
of the
just the
also...
call-out conjecture.
So, n, 1. You can work this out a bit. Basically, this is either 2, and nothing gives you 1. So this is fixed to be 2. You can either have a 4, you can either have a 4 here, or you can have anything else. 4 is fixed here. You can have an 8 here, you can have a 1 here. So that's the branch off. For 8, you can have either 16, you can have 16, and I don't think anything else gives you 8. So only 16 gives you 8. For 1, only 2 gives you that. For 16, you can either have 32 or 5. For 2, you can just have 4. You can't have anything else. For 32, that's only achieved by 64. 5 is achieved by 10. That's it. 4 is achieved by 8 or 1, which means that the sum is 83. Yes? Let me test just each one of these just to make sure. 64, 32, 16, 8, 4, 2, 1 works. 10, 5, 16, 8, 4, 2, 1 works. 8, 4, 2, 1, 4, 2, 1 works. 1, 4, 2, 1, 4, 2, 1 works. 83 is the answer. Nice. That's the correct answer. That's a nice problem. I like that problem.
Eh, I'm kind of annoyed that it's like it's not really that original.
All right.
But come
Uh,
on, that's literally the Watt's conjecture. Come on.
all right. Let me see if my hotkeys work. Okay, 23. We're almost done.
Home scratch. This is where it's supposed to get bashy, isn't it?
Hopefully it
Perhaps.
doesn't. Okay. Is the problem gonna update? Did I even click right key? There we go. Okay. 5 different awards are to be given to 3 students. Each student will receive at least one award. How many different ways can the awards be distributed? Oh, are the awards distinguishable? I don't think they are. So,
The award, it says different awards.
oh, really? Okay, so the
Yeah.
awards are distinguishable, and the students are also distinguishable, I think. Well, there's only a few ways to do this. So, you have 3-1-1, 2-2-1. I think those are the only possible ways. Yes, those are the only possible ways. So, you have to pick a student that receives 3 prizes. So, they receive 3 prizes. Let me just do this another way. So, case 1, case 2. For case 1, you have to pick the student. So, that's 3 times. Then you have to pick the 3 prizes they get, which is 5 choose 3, which is 10. Then for the remaining 2 students, you get to pick what prizes they get. Uh, for the next student, you pick one of the remaining 2 prizes, and the other student gets forced the last one, which is 60 for the first case. Second case, you're going to pick, well, actually, you can just fix the students and do this anyways. So, well, 3 to pick the unlucky student who gets only 1 prize, because they're unlucky. You have 10 ways to give this, the first student 2 prizes. You have 3 ways to give the other student 2 prizes, and the last prize is forced, which is 90. 150. B. Think I did anything bad there. You can't have 3 ones. You only have 2 ones or 1 1, and you can't have 2 2 2. Yeah, I think that's right. Don't say anything wrong with that. Let's move on. Call me out on anything if I make any mistakes. Let me know if that's wrong. Should be correct though.
I do not know if it's correct because I don't like Bashy combo.
It's not bashy. It's just, I mean, it's only 2 cases.
I still don't like it. I don't know. Every combo is just kind of like there's no really like good way to do it. It's just kind of
All
do
right,
it.
number 24. What is this asking? A large square is paved with n squared gray tiles, each measuring s inches on the side. A border d inches wide surrounds each tile. The figure below shows the case where n equals 3, where n equals 24. Find 76 tiles cover 6 points of a large area. Was huh. All right. This is very similar to an AMC 8 problem, not AMC 10 problem, or early AMC 10 problem, if you guys remember that. If you mocked any of them, you would remember. So, it's a good way to do this. You're going to find. So, the 576 gray tiles cover 64% of the area of the region. So, the area of the region is going to be 24S. Yes. Yes. Plus 25D squared. Yay. Wait, no. Yeah. And so that's the total. So basically, 24S squared. No, it's 576S squared. 576S squared over 24S plus 25D squared is equal to 64 divided by 4, which is 16 over 25. Yay. For this, you can fix s is equal to 1. It won't change the answer. I mean, it won't change the ratio, basically. So 576 over 576 plus 600. No, it's 1200. D plus 625 d squared is equal to 16 over 25. What is this computation? Yeah. This is not nice computation. I do not like it one bit. So you get 576 times 20. Oh my god. I see a better way to do this. I don't think there is a
Oh
better way to do
no. I don't like that. This problem is just kind of do math and then
this.
yeah.
No.
And then hopefully
What
you
is
get the
this? Why is
description.
this a thing?
Who knows? Who knows?
This is the worst AMC 8 problem I've ever seen. Oh, it's like 100? I hate this so much. What is this spam? What am I looking at on my screen? So you can solve a quadratic.
I really don't think that's necessary. Well, maybe that is necessary. I
Oh,
actually
you're
don't know.
right. I could square root. Oh, bruh. I'm so dumb. You're correct. I did not see that. Yes, I am dumb. Thank you for catching that. I am very stupid. Yes, you do square root both sides. This is not a good look for me. It's okay. I mean, I think my brain is fried, so if you square root this, you get not 28. What am I doing? 24s over 24s plus 25d. Thank you for catching that. Over 4, 5. If you let s equals 1 to simplify computation, this becomes 24 over 24. If you let s equals 1, yeah, 25d is equal to 4/5. So you get 5 times 24 is equal to 4 times 24 plus 100d.
Oh,
D is equal to 24 over 100. Yay. Let me see the answer choices. That is 6 over 25, and we are done with that problem.
oh my god, this problem.
A.
Dude, what prompted you to say Harry is smart? I don't know. I wasn't really listening. What happened?
So that problem's done. Final problem. I wish I had a soundboard, but I don't. All right, let's look at this problem. This is a cool problem. I'm looking at my paper right now. I don't know if it's up in. Okay, up in stream. All right, so rectangles R1, R2, and squares S1 and S2 and S3 are shown below, combined to form a rectangle that is 3, 3, 2 units wide and 20 units high. Well, this is kind of like a system of equations, type of spam thing. Uh, looks from the equation. I mean, it looks from what it looks like is so S1 plus R2 width is equal to 3. How do you find this 2? Give me a second. Oh, so that's not bad. It's the overlap of S2 and S3. 322, 2020. That's equal to 3322. And then S1 plus R1H. Actually, Yeah, S1 plus
I
R1H.
don't see. I don't know why this problem is in problem 25.
So if you subtract those, you get that the difference in the width and the height of R2. Is that even relevant?
Actually, I think you're doing too much work for this problem.
Can I use a diagram to scale?
Actually,
I,
you're really doing too much work for this problem.
listen, my brain is fried, okay?
Just like ignore R1 and R2.
Okay, let me think about this, okay? I'll
So
think.
the squares have nice
The
properties.
diagram is not to scale.
Alright, I meant to just use the squares. The squares have nice properties, whereas the
Yeah, I
rectangles do
know.
not.
All right, so S1 plus S3 plus S2 is equal to 3322. S1 plus S3 minus S2 is equal to 2020. Subtract both equations, you get 2S2 is equal to, what's this? 1312. Is that it? Yes. Anyways, is that the right subtraction? No, that's 1302. I cannot subtract. So this gives you S2 is equal to 651. That's A. Are we done?
Oh boy.
Well, I'd like to thank you all for coming and watching the stream. Uh, thank you all. I hope this helped people who may have had any trouble with any questions on any questions. This will be up on our YouTube channel forever if you ever want to refer back to it. But thank you for all who came out and watched this video. Really appreciate it. I mean, it's kind of late too, so for the East Coast at least. Thank you everyone so much. I guess that's it. I mean, here, do you have anything else to say?
Goodbye.
I have other things. Okay, please subscribe if you haven't already. We roll out lecture content almost every 2 weeks. Now, we probably won't do an AMC 10 live solve. I think that's a bit too. Well, we'll see. I don't know. But I hope you guys actually, I hope you guys learned stuff from this video or enjoyed watching it. And yeah, if you like this video, subscribe, leave a like, all that stuff that YouTubers say at the end of their videos, but I'm not a YouTuber. Yeah, see you guys later. Have a good night. Goodbye.